Hello everyone, this is Nash. Today what I want to share with you is something about phasor. Phasor is not like a vector, but actually is so much like a vector. A vector, you cannot change its direction, but for phasor, it is actually a rotating vector. It's now rotating around the style, which is now pivoted to the origin. The reason why we need to learn the phasor is it can help us to combine two waves, even though they get different amplitudes, and even though there are some phase difference between the two waves, I can still add them elegantly. Otherwise, you will just try to add them directly, violently, and by using some complicated mathematical methods, trigonometry, something like that. So phasor diagram is a very useful tool for us to combine the two waves. And how to define a phasor? First, I need to decide the size. Imagine there's a wave which is now passing by, and the R1 means its amplitude. I'll take this as our phasor, and this tail should be fixed to the origin. When a wave is now passing by, and all the median is going to oscillate in a simple harmonic motion. So the y1 is now a function of time. A function of time. It will start to oscillate in a sinusoidal way. And how to use a phasor to describe this kind of behavior? Because y1, as you can see, when the wave is now moving to the right, then the next moment, and the y1 will going to be decreasing. And how to use a phasor to describe this kind of behavior? That's very easy. All the thing you need to do is by rotating your phasor, because when your phasor is now rotating, remember the size should be fixed. When your phasor is now rotating clockwise, and the projection along the y-axis will be decreasing as well. So this is how we use a phasor to describe a wave, to describe the oscillation of the median, to describe the displacement of a median. All right, so imagine if I got a second wave. The second wave, they get different amplitudes, and there's a phase difference between the first and the second wave. And how to combine these two waves? The trick is I can just treat them like vectors. First, I'll show you how to draw the phasor of our second wave. If this is the phasor of our first wave, and projection along the y-axis means the displacement of the median. And now the second wave, the amplitude is R2. I can draw the second phasor as R2, and the projection along the y-axis is Y2. So now I want to combine these two waves. How to do so? Now you can treat them like vectors. Do you know how to add vectors? If this is a vector A, and you want to plus vector B, and the resultant vector is C. Simply by connecting the head and the tail, it is the resultant vector. So this is the same way how to add these two phasors. It's simply by shifting the phasor to the second phasor, and the tail is going to be attached to the head of the first phasor, just like you are adding two vectors. So I can shift the phasor 2 down like this. You're going to treat them like vectors. So the resultant phasor is simply by connecting the head and the tail, and this is the resultant phasor. I write it down as R prime. And the projection along the y-axis, I'll call it as y prime. This is quite simple, right? And how to describe, how to find out the phase difference? How to draw the phase difference? The phase difference is the angle between the first and the second wave. Your first phasor is now rotating with an angular speed, just like the angular frequency of the wave, and so is your second phasor. And the second phasor, got a phase difference phi between the first and the second wave, the first and the second phasor. So this is the phi. This is your phi. So I draw a dash line. This is your phi. Okay, so the resultant phasor, the resultant wave can be simply written down as the y prime of xt is equal to r prime and times sine of kx minus omega t and plus beta. Maybe you can now try to think, what is beta? And what is beta? Beta is some kind of angle. What is beta? Where should I draw it? Okay. Now, the beta in your holiday textbook is called phase constant. Because your first wave and the second wave, they all get the same angular frequency, so your phasor is going to rotate with the same angular speed, just like the omega. And since they are rotating with the same angular speed, they are rotating with omega. So the resultant wave, the angle between each one of them will also be fixed. So the beta you can be understood like the angle between the resultant phasor and the first phasor. This is the beta. Beta is called the phase constant, and it should also be fixed. They are moving together. They are just like moving with the same angular speed because they all get the same angular frequency. All right, so this is called the phase constant, the beta. It will also be fixed as well. So this is how we use the phasor diagram to combine the two waves, even though they get different amplitudes, even though there are some phase difference between them. I can still treat them like vectors. You can just add them all together beautifully, elegantly, instead of adding them using complicated trigonometry. All right. Another biggest advantage of learning phasor diagram is in high school physics we learn something about the single slit diffraction, but the only thing we know is the position of those diffraction pattern. There's no way for us to know how bright and how dark those pattern is. If we want to calculate the intensity of the diffraction pattern, and the phasor diagram is a very useful tool, because according to Huygens principle, we know that inside a single slit there are thousands of wavelets. They are emitting their own electromagnetic wave, and each one of them, they get their own wave function. But the biggest problem is for each one of them, they get different phase. So if you want to add them all together, you need to use phasor diagram. That will be much easier for us to calculate the thousands of wave function. So maybe I'll share with you in the future how to calculate the light intensity, the intensity of the diffraction pattern for single slit or double slit. All right. Thanks for watching, and this is Nash.